So today we are going to study one-dimensional arrays. The learning objectives are to understand the need for arrays, to know what is array and the types of arrays, to declare initialize the one-dimensional array, to understand memory representation in case of one-dimensional array, and finally to write C programs based on one-dimensional array. The session outcomes are the students will be able to understand what is array and types of arrays, how to declare initialize one-dimensional array, what is the memory representation of one-dimensional array, and to write simple C programs based on one-dimensional arrays. So, before understanding what is the arrays, we have to know what is the need for arrays. See, to store two values, we use two variables, and to store five values, we can use five variables. But basically, what happens if we want to store hundreds of values, say names or marks of students, then it is difficult to declare so many variables. So, in this case, the best solution is using arrays. So we can define the array like this. An array is a collection of one or more values of the same data type. Each value is called an element of the array. Each element has its own unique number. It is known as index or subscript. And an array can be of any type. For example, integer, it may be float, it may be character, etc. And what are the different types of arrays? See, the arrays can be categorized as one-dimensional array or 1D array, which contains single subscript. The second one is two-dimensional or 2D array, which contains two subscripts. The number of subscript or index determines the dimensions of the array. An array of one dimension is known as one-dimensional array or 1D array, and an array of two dimensions is known as two-dimensional array or just simply 2D array. Now coming to one-dimensional array. So a one-dimensional array is a collection of one or more values of the same type. So it can be represented like this in this diagram as shown below. So declaring an array, that is marks, to store the marks of 5 students. So we can give like this integer marks into square bracket 5. So here 5 is nothing but the size of the array. Also it is nothing but for 5 students we are giving 5. For 10 students we may have to give 10. So in the diagram we have 10, 20, 30, 40, 50, and here down in the second row we are having 0, 1, 2, 3, 4. This is the subscript or the index. So now let us discuss the syntax to declare one-dimensional array. So data type, array name, and into square bracket we have to specify the size. The data type, it is nothing but the type of the elements in the array, and the array name is nothing but the name of the array, and it must be a valid identifier or variable. The size, it is nothing but the number of elements an array can hold. For example, integer name of 50, float temp of 10, character ch of 40. And we can also use the variables and the symbolic constants to specify the size of the array. Now, how do you initialize one-dimensional array? There are basically three ways to initialize the one-dimensional array. The first one is initialization at the time of declaration itself. That is, int marks of 5 is equal to, we can specify the numbers here. And while initializing one dimensional array, it is optional to specify the size of the array. For example, like this, float temp is equal to, like this we can give. So temp is nothing but the array name. Here we are not specifying the size. Float is the data type, and here these are the values. The second way is assigning the value within the program, like this. Marks of 0, that is the first element. In the first element I would like to store 30. So we can use like this. So this is the second method. The third method is reading the values from the keyboard and then storing them in the one-dimensional array. For example, here we can give a for loop for I is equal to 0, I less than 5, I plus plus. So where I starting value is 0, every time it will be incremented by 1, and maximum 5 values we can store, or 5 marks we can store like this. So scanf %d ampersand of marks of I. So first time whatever marks I enter, that will be moved to the first element. When the I value is incremented, the second marks, okay, I entered, it will be moved to the second element, and so on. Then processing one-dimensional arrays. How do you store the data in one-dimensional array? So this is a small part of the program. So here in printf we are having enter the elements one by one. So here I have given for I is equal to 0, I less than 5, I plus plus, and scanf. So it is going to store the elements or data into the array. In the same way, displaying the data from one-dimensional array. So instead of scanf here, we are using printf in order to print the values from the array on the screen. Then how do you access the elements of one-dimensional array? Specifying the array name followed by the subscript or index inside the square brackets. For example, if I want the first element, then I would like to give 0. So because the array subscript or index starts at 0. The first valid subscript 0 is known as the lower bound, while the last valid subscript is known as the upper bound. And array subscript or index can be any expression that yields an integer value. To display the second element in the marks array, okay, so we can use like this, printf %d marks of 1. So 0 is the first element, so marks of 1 is nothing but the second element. And to replace the fourth element with 85, we use marks of 3, okay, is equal to 85. So this 85 value will be stored in the array called marks at the fourth place. Then how the memory representation is there in case of one-dimensional array. One-dimensional arrays are allocated in continuous block of memory, that is continuously it will be allocated. All the elements are stored next to each other. For example, integer a of 4, okay, 10, 20, 30 and 40. Each element in an array has a unique subscript value from 0 to the size of the array. So I can give a is equal to, a of 0 is equal to 10, a of 1 is equal to 20, a of 3 is equal to 30, and so on. As there are 4 integer elements, the array occupies total 4 into 2 is equal to 8 bytes. And let the memory allocation start at value 100. So the memory representation will look like this. So a of 0, this is the first element, second element, third, fourth. So 10, 20, 30, 40. So this is the memory allocation. Memory location start value 100, 102, 104, 106. Then first we are going to see some of the programs. The first program is to input from the keyboard and print the elements of one dimensional array. So here the program, in the initialization section we have an array called ARR and one integer value I. So here I am going to enter the values. So I am giving printf and then scanf, enter the array element, then scanf. Then it will print the elements of the array after that. So for I is equal to 0, I less than 5, I plus plus. So it will print and then it will return 0 to the operating system. So I have given here int main. So you can see the output also. Enter ARR of 0 is 11 and here ARR of 1 22, ARR of 2 34, ARR of 3 is 4 and ARR of 4 is 34. And then it will print their elements of the array one by one, 11, 22, 34, 4 and 34. The second program is basically to print the sum of the elements of an array. So here we are having an array called ARR. For subscript or index I have taken I, and for finding the sum I have taken S and initialized to 0 in the beginning. Then here in this loop I am going to print, enter the array and then I am going to accept, and for in this particular for loop I am going to find the sum. So I is equal to 0, I less than 5, I plus plus, and S is equal to S plus is equal to ARR of I means S is equal to S plus ARR of I. Then finally I am going to print the sum of the elements. So the output is like this. You can see the output also. So first element I have entered is 22, then 33, 56, 73 and 23. The sum of the elements, all these will be stored in S and it will display the sum of the elements as 207.